Hello, some people are having problems with the calculations on this worksheet, and so I am going to go through and give you a little preview of how to put it all together, and then we'll do some problems together. I also noticed some people weren't doing their pH scale. This is straight out of your notes. Make sure that you have your notes so you can understand these questions, and in the notes I do these type of questions too. So the first thing that you need to understand is how our ionic compounds break apart in water. Here I have barium hydroxide. Notice there are two hydroxides there. So when barium goes into solution, it makes a barium 2+, and then two OHs, which are ions, so they are minus. So if I wrote the dissociation equation for this, it would be barium is, barium hydroxide is going to break apart into a barium ion, so we have a charge, plus, notice there are two hydroxide ions. Okay, two OH minuses. Now, let's say that I put in a concentration of 1 × 10⁻⁶. This is like Legos. I have one red and two blues. Okay, but this is all one grouping, and that is the concentration. So if I break this apart, I have one of this grouping. I made one barium, so it's going to have the same concentration, 1 × 10⁻⁶ molarity. But this guy has two ions in solution, so that's going to have twice the concentration. So that would be 2 × 10⁻⁶ molarity. So when we break them up, you have to be careful that we have the correct number of ions, and then of course if I only have 1 ion per liter versus 2 ions per liter, I have double the concentration, and we measure concentration in molarity. The second part of this worksheet is to make sure that you understand when you run things in water, it's in equilibrium with the water dissociation. So water also breaks apart into H+ and OH. That's in equilibrium. So we have our K, our equilibrium constant of water, equals the concentration of the H+ in solution times the concentration of the OH-, and these two numbers will always equal 1 × 10⁻⁴ will always equal the H+ concentration and the OH- concentration if it's run in water. So we have a concentration of 2 × 10⁻⁶. So we're going to plug that in our OH because it's OH, and then I can find, because it's run in water, I can find how many hydronium ions are in water, and then we'll use this hydrogen ion concentration or hydronium ion, you can call it either one, later to decide what the pH is. But that's another lesson. Okay, so we need to figure out the molarity of either the H+ or the OH+ in whatever solution we put in, so we can plug it into this equation and we can solve for either the H+ or the OH-. It depends on what's going in solution. This, we have OH is going in solution, we don't know the H+. I can solve using the equilibrium expression for water. Okay, so let's go to our worksheet and see how that all works out. I am going to do two examples. The example on your worksheet I'm going to explain. And then I also want to, since this is an H+, I want to show you an OH. So I'm going to do these two guys. Let's get close so we can see what's going on here. And the first thing I need to do, according to the directions, is write the equation with concentrations below it. So my HCl will, let's see if we can get a better angle of that. Yeah, HCl will break apart into one H+, there's only one of those, and 1 Cl minus. Now it tells me my concentration is 0.005, and we're not going to worry about sig figs right now. I want to keep this clean so you can see what's going on. If I have one of these things, it will break apart into one hydrogen, and let's say it's in a liter, so it's molarity, so it's 0.005 per liter. There's only one of these guys, that's going to be 0.005, right? These are all molarity, and 0.005 molarity. So now, what do we have? We have our H plus concentration. That's this guy right here. So I can just write my H plus molarity equals 0.00, and here I am going to finish with that sig fig molarity. Okay, so I know my H. So how do I solve for my OH? Well, we are going to use our KW expression, which is 1 times 10 to the negative 14th equals concentration of H plus, concentration of OH minus. Okay, so what we have here is 1 times 10 to the negative 14th equals concentration of H plus, which is 0.005, times the concentration of OH, whatever that is in solution. Okay, so I'm going to divide both sides by 0.005, and that's going to get my OH alone. Let's remember how to put things in our calculator. So I want 1 times 10 to the negative 14th, so I have to go 1 exponent, no times, no 10, and here I have a negative sign, negative 14 divided by 0.005, and that will give me my OH is going to equal 2.0 times 10 to the negative 12th. Why did I use 2 sig figs? Because I was given 2 sig figs in my problem. Ooh, you guys can't see that. Okay, so that's the first one, and they gave us the H, so I put my given there. Let's go down to this problem right here with barium hydroxide. This is a little different. Barium hydroxide, and there's 2 of them, is going to break apart into barium 2 plus, because it's an ion now, make sure you have your ions, plus there are two OH minuses here. And again, if you want to keep that in parentheses, you can. So let's look at our concentration. There's one of these guys times 10 to the negative 6th. It broke down into one of these guys, so that's going to be the same concentration, times 10 to the negative 6. This guy broke down into 2, so I have to double it. 6.0 times 10 to the negative 6. Okay? And now, we need to, for this worksheet, we're solving for OH and H, and we're given one here. Here, we're given the OH. So I am going to write that my OH concentration is going to equal, oops, my negative should be in there. Sorry about that. 6.0 times 10 to the negative 6 molarity. Okay, remember brackets mean molarity. Cool. Now, how do I find the H? Well, this is run in water. All these solutions are run in water, and we are to use this formula to figure out the other guy. Given one variable, solve for the other one, and we're solving for our H plus. So 1 times 10 to the negative 14th equals, I'm given my H plus this time, or I'm solving for my H plus this time, so that's my unknown variable, and my OH is 6.0 times 10 to the negative 6th. So what am I going to do? I'm going to divide both sides by 6.0 times 10 to the negative 6th. 6.0 times 10 to the negative 6. Why? Because that gets rid of that side, and now my H plus equals 1 times 10 to the negative 14th divided by 6 times 10 to the negative 6. So again, let's double check that we can use our calculator correctly. And I have 1 exponent 14 negative. That's how my calculator works. Don't use this negative sign. Your calculator should have one of these. Again, it depends on your calculator. And then I'm going to divide by 6 exponent negative 6. And I am going to get this number, which of course I don't like, so I'm going to go second function scientific. Whoa, that took me to another thing. Let's do that again. Second function scientific. I think I have it in scientific now. Okay, 1 exponent 14 negative divided by 6 exponent 6 negative, and that's going to give me 1.66 times 10 to the negative 9th, or my h plus, I'm writing below, but this is all the same problem. Your columns will spread apart and give you room. H plus is going to equal 1.7 times 10 to the negative 9th. Notice I'm in the correct column because I'm solving for H plus. They gave me OH, I wrote it there. Okay, so that's how you're going to do those problems. The last problem, we're given a concentration that tells me 40 grams is dissolved in 1 liter of water. So you need to change it into molarity to do the problem the same way. There's a video here that will guide you through it if you're lost.